Hey everyone, welcome to LAKNARA Education. In this video, we are going to talk about the memory and its components. Let's go on. First, let's talk about the memory. Memory is divided into two types as primary memory and the secondary memory. Primary memory is the memory that the CPU directly uses data for processing. It's fast and temporary, storing data that is currently in use. It can be considered as a volatile memory. And primary memory can be divided into two main types as RAM and ROM. The secondary memory is for long-term storages and retains data even when the power is off. It is a non-volatile memory. Examples for secondary memory include hard disk drive, solid-state drives, DVDs, and pen drives. RAM is the working memory of a computer. RAM is used for temporary storages while the CPU is working. It is volatile, meaning it loses its data when the power is off. RAM is divided into two main types as SRAM and DRAM. SRAM is faster and does not need to be refreshed, used for fast and temporary data. SRAM is further divided into registers and cache memory. DRAM is slower and needs to be refreshed. It used for general storages for data during processing. And the ROM. ROM is stand for read-only memory. ROM stores permanent data needed for computer to start up and run. It is a non-volatile memory, meaning it keeps data even the power is off. There are different types of ROMs, that is PROM. It can be written once but not changed. EPROM, that is erasable programmable ROM, can be erased with UV light and rewritten. And the third type is double EPROM, that is electrically erasable programmable ROM, can be erased and rewritten using electrical signals, making it easier to update. Now, primary memory or the volatile memory, it's known as a volatile memory because it loses its data when the data is power off. And ROM is a non-volatile memory because it keeps data even when the power is off. Also, the secondary memory, also a non-volatile memory designed for long-term storages. Volatile memory versus non-volatile memory. Volatile memory temporarily stores data while the system is on but wiped clean when the power is off. Think of a RAM as a whiteboard. Easy to write and erase but loses everything when cleaned. Also, volatile memory is great for multitasking. And now let's see what is non-volatile memories. Non-volatile memory, on the other hand, keeps your data safe even the power is turned off. Hard drives are like notebooks, they stays until you erase it manually. Non-volatile memory is essential for saving files and booting up your operating system. And now let's talk about the memory hierarchy. Memory hierarchy. Computers have different types of memory and they are organized in hierarchical based on three main factors like speed, size, and cost. Registers. At the top of the hierarchy we have registers. Registers are the fastest type of the memory in a computer and they are located directly inside the CPU. This makes them extremely fast, but because they are small and expensive, there are only limited amount of them. Registers are used to store data that the CPU is currently working on. They are like CPU's personal workspace. And the second one, next we have the cache memory. Cache is still very fast, but it's slightly slower than the registers. It stores frequently uses data to keep the CPU access it more quickly. Cache memory is faster than the RAM, but it is also smaller and more expensive. The CPU uses cache to avoid having to go all the way to RAM for data that it needs frequently. And third one, we have the RAM. It is much larger in size than registers and cache, and it also slower than both. RAM is where the computer stores data that is actively being used by running programs. When you open an application, it loads from your hard drive into RAM so the computer or the CPU can work with it more easily. RAM is cheaper than cache and registers, and it is main working memory on the system. And also, at the bottom of the hierarchy, we have the secondary storages like hard disk drives, solid state drives, and other long-term storage devices. These offer huge storage capacities, but they are the slowest form of the memory. Secondary storage is where the data is stored for long term, like your files, documents, and programs. Although it is much lower than the RAM, it is inexpensive and can hold lot more data. Why the memory hierarchy matters? The memory hierarchy is essential because it helps to balance the performance and the cost. Registers and cache are the fast, but they are small and expensive, so we use them to store the most critical data that the CPU needs immediately. RAM is larger but slower, and it's slow data the CPU needs access to while working on the tasks. Secondary storages provide the most space but is much slower, so it is used for long-term storage of data that is not needed immediately. The hierarchy helps the computer to optimize the performance by using the fastest memory for most critical data and using slower memory for less urgent tasks. This balance ensures that the computer can work efficiently without being too expensive to build or operate. This one thing we should know is when the access speed increases, the access time decreases. When the access speed decreases, the access time will get increased. So when we order the memory components in ascending order by capacity, we'll get that order as the registers, the L1, L2 and LT cache, and then the ROM, RAM, and lastly you get the HDD or the hard disk drive. When we order up the memory components in descending order of the access speed, we get it as registers, L1, L2, L3 cache memories, and then RAM, ROM, and HDD. Cache memory is essential for performance. It stores frequently accessed data closer to CPU, reduces delays. There are three levels as L1 is the fastest and the smallest one, L2 is larger but slower, and L3 shared across cores, offering even more capacity. The purpose of the cache memory is reduce the time to access frequently used data and improves the overall system speed. As we all know, cache is a small and fast memory that stores data in the CPU that uses often, making it quicker to access. Cache hit happens when data is already in the cache. So it loads instantly, like when you revisit a website and it loaded quickly. A cache miss occurs when the data is not in the cache, so the system has to get it from the slower memory, which take longer, like when you visit a website for the first time. Cache hit speed ups the performance, while cache miss slow things down. What is DRAM? DRAM stands for Dynamic Random Access Memory. It's a type of memory used in most computers because it is cheap and can store a lot more data. However, DRAM stores data in tiny capacitors that need to be constantly refreshed to keep the data. If they are not refreshed, the data is lost. This refreshing happens thousands of times per second. which make DRAM a bit slower than other types of memory like SRAM. But because it is cheaper, it is used in your computer's main memory as the RAM. What is SRAM? SRAM, which stands for Static Random Access Memory. It is a type of memory used in computers. Unlike DRAM, which need to be constantly refreshed, SRAM uses flip-flop circuits to store data. These circuits hold data as long as the power is on without needing to refresh, making SRAM faster and more reliable than DRAM. SRAM is mainly used in the cache memory, which is small, super-fast memory located near the CPU. It stores data that CPU needs frequently so it can access it quickly, speeding up the computer. However, because SRAM is more complex to produce, it also more expensive than DRAM. So, while it's faster and more reliable, it's used for high-speed tasks where speed is more important, like cache memory, but not for general storage. SRAM versus DRAM. In summary, DRAM and SRAM serve different purposes. DRAM is cost-effective and used for general memory, while SRAM is faster and more reliable, making it ideal for critical high-speed applications like cache memory. Both types of memory are essential for balancing performance and cost in modern computer systems. What is SDRAM or synchronous DRAM? It is an improved version of DRAM. It works in sync with the system clock, meaning it coordinates data transfer timing to be more efficient and predictable. This synchronization allows for better performance than standard DRAM, though it is now considered outdated. What is DDR-SDRAM? DDR-SDRAM or Double Data Rate SDRAM is a faster and more efficient version of SDRAM. It achieves higher performance by transferring data on both rising and falling edges of the clock cycle. DDR-SDRAM is the foundation for RAM we use today, evolving into versions like DDR2, DDR3, DDR4, and DDR5. What is ROM? ROM stands for Read-Only Memory. It is a type of non-volatile memory, meaning it retains its data even when the power is turned off. Unlike RAM, the data stored in ROM is permanent and cannot be easily modified. It is primarily used to store firmware. These are essential instructions that help a computer or device operate, like boot process for starting up the computer. ROM is crucial because it provides a reliable, unchanging data that the system can always access. ROM, or the read-only memory, is essential in computers and devices for storing permanent data. There are three main types of ROM, that is PROM, EPROM, and double EPROM. PROM stands for Programmable ROM. PROM is blank when made and can be written to only once using a special device called PROM burner. Once written, it can't be changed, making it idle for fixed data in devices like calculators and appliances. EPROM, which is erasable programmable ROM, can be erased and reprogrammed, but it requires UV light to erase data. It's useful using development phase when you need to modify data multiple times. And then double EPROM, that is electrically erasable programmable ROM. Double EPROM is the most flexible one. It can be erased and rewritten electronically. Also, you can change specific bits of data without removing the chip. This is great for updatable systems like BIOS in computers, where updates are needed over time. To summarize, PROM is used for fixed, unchanging data. EPROM for development where data changes, and double EEPROM allows frequent easy updates, perfect for modern devices. Secondary storages. Secondary storages is where we store data for long term. It's different from the main memory because it keeps data even when the computer is off. There are three main types as magnetic, optical, and solid. Magnetic storages includes hard disk drives, floppy disks, and etc. They are affordable and offer large storage capacity, but they are slower. Also, the disk should be rotated to read data. And the second type is the optical storage. Some examples are CDs, DVDs, and Blu-rays. They are portable and durable and often used for movies or music. A laser beam is used to read and write data. And also the disk should be rotated as in the magnetic disk to read the data. And the third type is solid state. This includes SSDs, USB drives, and memory cards. They are faster and more durable, but also more expensive. But this type has no moving parts, so rotation is not needed. Memory access methods. There are two main ways to access data. One is sequential access, other one is the random access. Sequential access is a method that data is read in order one after the other. This is slower but works well for tasks like backup where the data does not need to be accessed quickly. An example is a magnetic tape. And the second type, the random access. Here, data can be accessed directly from anywhere without having go through everything before it. This is much faster and is ideal for tasks like multitasking and real-time processing like in RAM and SSDs. In short, sequential access is slower but good for backups, while random access is faster and better for everyday tasks.